Hi everyone, once again welcome back to our lecture series on polynomials. In our last lecture we have seen the graphs of constant polynomial and linear polynomials. Today we are going to discuss about the graph of quadratic polynomial. In our last lecture we have seen that how to find out the zero of a polynomial graphically. To obtain the zero of a polynomial graphically, first of all, draw the graph of the polynomial and obtain the point of intersection of the graph with the x-axis. And we have seen that a constant polynomial has no zero and a linear polynomial has only one zero. So how do you obtain the point of it? How do you obtain the zero of a polynomial graphically? Just obtain the graph of the polynomial and obtain the point of intersection of the graph with the x-axis. Now let us consider the quadratic polynomial and its graph. So what is the general form of a quadratic polynomial? F of x is equal to ax square plus bx plus c, where a not equal to 0. So this is the general form of a quadratic polynomial. F of x is equal to ax square plus bx plus c, where a not equal to 0. Is a quadratic polynomial that we have seen in our first video. See, those who didn't watch my previous videos, just try to watch it first. Okay. F of x is equal to ax square plus bx plus c, where a not equal to 0 is the general form of a quadratic polynomial. See, first of all, you must understand one thing, that the graph of a quadratic polynomial is either a parabola open upwards or a parabola open downwards. So these are the two shapes of the graph of a quadratic polynomial. So first of all, you must understand one thing, that the graph of a quadratic polynomial is, this curve is called, or this shape is called a parabola open upwards, and this is the parabola open downwards. So the graph of the quadratic polynomial ax square plus bx plus c will be a parabola opened upwards if a is greater than 0 or if a is positive. So if a is positive, what is a? A is the coefficient of x square. If the coefficient of x square is positive, that is if a is positive, the graph of the quadratic polynomial will be a parabola opened upwards like this. And if a is negative, or if a is less than 0 means a is negative. If a is negative, the graph of the quadratic polynomial will be a parabola open downwards. See, this turning point is called the vertex of the parabola. This is the parabola open upwards, and this turning point is called the vertex of the parabola. In this case, this is the vertex. See, in the chapter quadratic equation, you will study in detail about these graphs. There you will study that this vertex is nothing but minus b by 2a minus d by 4a. This will be the vertex. In this case also the vertex will be minus b by 2a minus d by 4a, where d is equal to b square minus 4ac. See, for the time being you need not bother about the vertex and its coordinates. That you will see later. See, for the time being you just understand that the graph of a quadratic polynomial is either a parabola open upwards or a parabola open downwards. It will be a parabola open upwards if a is greater than 0, and it will be a parabola open downwards if a is less than 0. That means a is negative. What is a? A is the coefficient of x square. Now let us consider a very simple example. Let us consider f of x is equal to x square minus 1. Clearly this is a quadratic polynomial or a second degree polynomial. F of x is equal to x square minus 1. How will you find out the zero of this polynomial algebraically? We have seen in our last lecture, I think, that to obtain the zero of a polynomial algebraically, just equate the given polynomial to 0. So let us equate the given polynomial to 0. That is x square minus 1 equal to 0, or x square equal to plus 1. Minus 1 when brought to the right hand side becomes polynomial algebraically, just equate the given polynomial to 0. Here it is x square minus 1 equal to 0, or x square equal to 1, or x equal to root 1, that is plus or minus 1. That means x is equal to plus 1 and x is equal to minus 1 are the zeros of the polynomial. X equal to plus 1 and x equal to minus 1 are the zeros of the polynomial. Now let us try to verify it graphically. So how will you verify it graphically? How will you find out the zeros of a polynomial graphically? Just draw the graph of the polynomial and obtain the point of intersection of the graph with the x-axis. First, let us try to draw the graph. So to draw the graph, what is f of x? F of x is taken as y. F of x is nothing but y. So y is equal to x square minus 1. How will you obtain the points? Now, x and y coordinates are to be calculated. See, give any value for x and then find out the corresponding value for y. Suppose x is equal to, what we can say, suppose x is equal to 0. If x is equal to 0, what is y? Y is equal to 0 square, that is 0. 0 minus 1 is minus 1. Suppose x is equal to 1, then what is y? Y is equal to 1 square, that is 1. 1 minus 1 is 0. Suppose x is equal to minus 1. If x is equal to minus 1, what is y? Minus 1 square. Simply substitute x equal to minus 1. Give any value for x and then find out the corresponding value for y. If x is equal to minus 1, what is y? Minus 1 square. What is that? It is plus 1. When we take the square of a negative number, it becomes positive. Minus 1 square is plus 1. 1 minus 1 is 0. When x equal to 2, what is y? 2 square 4. 4 minus 1 is 3. When x equal to minus 2, what is y? Minus 2 square. Minus 2 square is plus 4 minus 1. 4 minus 1 is 3. Now let us plot these points in the xy plane. So here we have the positive direction of x-axis 1, 2, 3, 4, etc. And this is negative direction of x-axis minus 1, minus 2, minus 3. And this is the positive direction of y-axis, and this is the negative direction of y-axis. Now let us plot the points, these points in the xy plane. 0 minus, I think you know how to plot the points in the xy plane. 0 minus 1. What is the point? 0 minus 1 corresponding to x equal to 0, you will have to mark minus 1. This is the point x equal to 0 and you will have to mark minus 1. So this is the point. Then 1, 0. Corresponding to the point x equal to 1, mark 0. That is, this is the point. Minus 1, 0. So this is the point x equal to minus 1. So this is the point minus 1, 0. 2, 3. Corresponding to the point x equal to 2, you will have to mark 3. Corresponding to x equal to 2, you will have to mark 3. So 2, 3. Minus 2, 3. So this is the point x equal to minus 2, and corresponding to this, you will have to mark 3. So if you join all these points plotted by a smooth freehand curve, then that will be the graph of f of x is equal to x square minus 1. Now let us join. So this is the graph of f of x is equal to x square minus 1. And we can easily understand that this is a parabola open upwards like this. So why we obtained a parabola open upwards? Because here the coefficient of x square, that is a, is positive. So here a, what is the value of a? X square means 1 into x square. Coefficient of x square, that is a is equal to 1. So here a is positive. Since a is positive, we got a parabola open upwards. Then how will you find out the zeros of this polynomial graphically? Just find out the point of intersection of the graph with the x-axis. So this is the graph and this is the x-axis. These are the points at which the graph intersects the x-axis, and these points are, this is x equal to minus 1 and this is x equal to plus 1. So the roots are x, or the zeros are, it is not roots actually. Roots are for polynomial equations. But for polynomials, we will we should say that it is zeros of the polynomial. I think for zeros, usually I use the word zero, roots. So you must understand that. So x equal to minus 1 and x equal to plus 1. So x equal to minus 1 and x equal to plus 1 are the zeros of the polynomial. So x equal, and we have seen earlier that x equal to plus 1 and x equal to minus 1 are the zeros of this polynomial. So a quadratic polynomial has two zeros. So how will you find out the zeros of a polynomial graphically? Just draw the graph and find out the point of intersection of the graph with the x-axis. So the graph of a quadratic polynomial is either a parabola open upwards or a parabola open downwards. It is a parabola open upwards if a is positive, and it is a parabola open downwards if a is negative. What is a? A is the coefficient of n square. Now let us see some questions based on this. Suppose we are given four graphs. See, one graph is like this, and the second graph is like this, and the third graph is like this, and the fourth graph is this. So these are the four graphs given in the question. See, we are given these four graphs A, B, C, D. You are required to find which of these four graphs does not represent a quadratic polynomial. Which of the graphs does not represent a quadratic polynomial. So this is a parabola open upwards. So this graph represents what? A quadratic polynomial. This is a parabola open downwards. So this graph also represents a quadratic polynomial. This again is a parabola open downwards. So this graph also represents a quadratic polynomial. But this is not a parabola. We have seen that the graph of a quadratic polynomial is either a parabola opened like this or a parabola opened downwards. So these two are parabola opened downwards, and this is a parabola open upwards. So these three graphs actually denotes a quadratic polynomial, but the fourth graph is not a parabola, so this graph does not represent a quadratic polynomial. Let us consider one more question. Suppose we are given four graphs. See, the first graph is like this, and the second graph, it is like this. This is the second graph, and this is the first graph. These are axes, x and y axis, and the third graph is this, and we are given one more graph which is like this. See, you are required to find out the number of zeros in each case. We are given these four graphs and you are required to find out the number of zeros in each case. How will you find out the number of zeros of a polynomial graphically? To obtain the number of zeros of the polynomial graphically, just draw the graph and find out the point of intersection of the graph with the x-axis. So here this graph intersects the x-axis at three distinct points. We will not consider this point. This is the point of intersection of the graph with the y-axis. So this graph intersects x-axis at three distinct points. So the polynomial represented by this graph has three zeros, or more precisely, three real zeros are there. See, how about this one? So this is the graph. This graph intersects the x-axis at only one point. So here this graph has only one zero. We can only say that one real zero. There may be zeros which are not reals. So in our last lecture we have seen that this is a constant polynomial. here no zero. This polynomial has no zero. Here this graph touches or intersects x-axis at three distinct points. So this polynomial or the polynomial represented by this graph has three zeros. So that now I think this concept is quite clear to you. So how do you obtain the zeros of a polynomial graphically? To obtain the zero of a polynomial graphically, draw the graph of the polynomial and then find out the point of intersection of the graph with the x-axis. Now let us consider one more board examination question. See, the graph of a polynomial intersects x-axis at three distinct points. The graph of p of x cuts x-axis at 3 points. Then, which of the following could be p of x? 4 options are there. P of x is equal to. So here we are given that a polynomial cuts, or the graph of polynomial cuts x-axis at 3 distinct points. First one is 4 minus 4x. 4 minus 4x minus x square plus x cube. And the second option is p of x is equal to 3x square plus 3x minus 3. And the third option is p of x is equal to 2x plus 3. And the fourth one is p of x is equal to x square minus 9. See, it is given that the graph of a polynomial p of x cuts x-axis at 3 points like this. The graph of the polynomial cuts x-axis at 3 distinct points. So how many zeros will be there? 3 zeros will be there. So if its polynomial has 3 zeros, it could be a third degree polynomial. Third degree polynomial will have 3 zeros. Second degree polynomial will have 2 zeros. First degree polynomial will have only 1 zeros. So 3 points of intersection are there with the x-axis. So this polynomial has 3 zeros. So if a polynomial has 3 zeros, it could be a third degree polynomial. In the given options, only the first option is a third degree polynomial. So this is a third degree polynomial. So first option is correct. I think this is enough for today. In our next lecture we will see more about polynomials. Till then, bye.